7-8, equation of a circle in standard form. To write the equation of a circle in standard form, we need two things: the center of the circle, h, k, and the radius of a circle, r. To write the equation, we have the following formula: x minus the x coordinate of the center, quantity squared, plus y minus the y coordinate of the center, quantity squared. And this will be equal to the radius squared. So let's see how we could apply this to several different problems. In example 1, we want to write the equation of a circle given the center and the radius. The first thing I'm going to do is label my center and radius with the following letters. The center will be our h and k. So let's go ahead and label 5, -2 as h and k. So that means in our formula, wherever we see an h, we'll put a 5, and wherever we see a k, we'll put a -2. Our radius will be our r. Okay, so let's go ahead and just start with the formula. X minus h, quantity squared, plus y minus k, quantity squared, equals r squared. All we have to do to write the equation is plug in our h, k, and r where appropriate. So the x and the y will always remain just x and y when you're writing a general form of an equation. Next, we'll write minus, because that's part of the formula, and the h value, 5, parentheses squared, plus y, again, that just stays generally y when we write an equation, minus, because it's part of the formula, and then the k value. Notice that the k value is -2. That means that I should add an additional negative because it's part of the k. That does not replace the negative that's already part of the formula. So once again, this first negative is part of the formula. The next negative is part of the k value itself. And finish it off, so quantity squared equals our r value, 7 squared. When we write our equation of a circle, we typically simplify a couple of things. The first is any double negatives usually turn into a plus sign. So wherever you see a double negative next to each other, we're going to go ahead and just replace that with an addition sign. So this will become y plus 2 squared. And the x will remain x minus 5 quantity squared. In addition, we typically simplify our radius and square it if possible. So 7 squared just will become 49. And this is our general form of the equation of the circle. Okay, let's go ahead and take a look at our next example. In our next example, we want to identify the coordinates of the center and the radius, then write the equation of the circle. So this is actually exactly like the previous problem, except the first thing we have to do is identify the center and the radius based on the graph. So let's first find the center. The center coordinate is that black dot right in the middle of the circle. It looks like the coordinates of our center will be -1, +1. Next, we'll find the radius. To find the radius of a graph, we typically will count up, down, right, or left from the center. Notice that we always count horizontally or vertical. The reason why we try to count horizontally and vertical is because we can just literally count the blocks and we don't have to do some more complicated math that we're going to have to do in another problem. So from here, we're just going to count up or down or right or left. So I'm going to go ahead and just count up. It looks like we have 2 blocks up, so that means our radius will be 2. So our center is -1, 1, and our radius is 2. This will be our h, k, and r. Now that we have our values, just like in number 1, we're simply going to plug them into the formula. X minus h quantity squared plus y minus k quantity squared equals r squared. So here we go. Parenthesis x minus, now the h value is -1. So I'm going to go ahead and replace the h with a -1. Notice that there are 2 negatives because the first negative comes from the formula and the second negative is part of the h value. plus y minus the k value squared, all equal to the r value, 2 squared. By the way, all of these little things like the squares and the addition sign separating the two terms are extremely important because without those squares, you don't have a circle. And without the plus sign, again, you don't have a circle. So if I ask you to write the equation of a circle and you do not include the plus sign or the squares, it will be wrong, and I will mark it wrong. Okay, so let's go ahead and simplify any double negatives and any numbers that can be squared. So I see a double negative here with the x term, so x minus a negative 1 turns into x plus 1 squared. Plus, y is just minus 1, so we'll just keep it that. And last but not least, 2 squared can be simplified into 4 squared, or I'm sorry, 4. And there's our equation for this particular circle. Okay, let's look at our most complicated example. Number 3. What is the equation of the following circle? Now I know you might be thinking, hey, this is the exact same thing as it was on our last problem. Why is this more complicated? Well, you'll see. Our center is going to be 1, negative 3, that blue dot right in the center of the circle. So that wasn't more difficult. H, K. However, our radius is more difficult to find. Notice that they gave you a point on the circle. Be careful. Anytime they give you a point on the circle, if that point is not directly above, below, to the right, or left, you cannot count the number of squares. I know it looks like the radius is 5, but since we're giving this point, we have to use the point to find the radius. And in addition, this can't be 5 because if this was a y value of 2, then the y value here we would expect to be slightly less than it, but it isn't. So when given a point on the circle, you're going to have to find your radius another way. So how do we find the distance diagonally? Here, we can do one of two things. We can either use the Pythagorean theorem by creating a right triangle by dropping a vertical line and a horizontal, and then using the Pythagorean theorem to find the hypotenuse. Or you can use the distance formula. It's your choice. Either way will work. Let's go ahead and use the distance formula in this particular example. The distance formula will be the difference of our x values squared plus the difference of the y values squared, all underneath a square root. So if we are using these 2 points, 2, 2, and 1, negative 3, as our points, and it doesn't matter which one's your x1, y1, and which one's your x2, y2, we would plug them in. So here we go, x2 minus y1, difference of x values, 1 minus 2. I probably should have labeled them the opposite way, but either way it doesn't matter. y2 minus y1, so negative 3 minus 2, quantity squared. And simplify. So 1 minus 2 will be negative 1. Negative 1 quantity squared is going to be positive 1. Okay, let's do the next one. Negative 3 minus 2 will be negative 5. Negative 5 squared is positive 25. So simplifying this, we get square root of 1 plus 25, or underneath the radical, square root of 26. 26 does not reduce because the only factors are 13 and 2, which neither of them are perfect squares, so we'll go ahead and just leave this as the square root of 26. And this is our distance, but the distance between these 2 points is also our radius. So this is our r. So we have our r, our h and k, and finally we're able to find the equation of the circle. So notice we had to do a little bit more work to find that radius when we're given a different point on the circle. So let's go ahead and go back to the formula. X minus h squared plus y minus k squared equals r squared. And again, this becomes pretty easy once you have all the components. X minus the h value, 1 in this case, squared, plus y minus the k value, -3 squared. And this will be equal to the radius. Now the radius is square root of 26, and then we have to square it. So we're going to actually square the square root of 26. And we'll talk about what happens then. Okay, so next let's simplify our equation. Anytime we see a double negative, we'll replace it. So x minus 1 doesn't have a double negative, but y minus a -3 turns into a +3. So y plus 3 quantity squared. And we also simplify our radius squared. So here we have the square root of 26 squared. So how does this simplify? I hope you're not reaching for your calculator, because the square root and the square are opposite operations. Essentially, they undo each other. So the square root of 26 squared just simply becomes 26. And there's our equation. One more problem to take a look at in this section. Identify the radius in the center. So this problem is actually backwards. They're giving you the standard form of the equation of a circle, and we need to identify the radius in the center. So what I'm going to do is I'm going to attempt to rewrite this equation so that it looks like x minus something squared plus y minus something squared equals something squared. All right, so let's do that. The first term looks like x minus something squared. So the first term's fine, x minus 7 squared. But our second term is y plus 2. So I need to rewrite that so that it looks like a minus sign. So just like we turned a double negative into a positive, we can turn a positive into a double negative so that we see that subtraction. And this will be equal to some quantity squared. So now the question is, what number, when squared, will give us 64? And it turns out that 8 squared gives us 64. So now essentially all we've done is rewrote the problem just using double negatives and finding the particular number when squared that's equal to 64. What we have left is our h and k value. So our h is the 7, so we see we see x minus our h value. And our k value is the -2. The reason why the k value is negative is because one negative applies to the formula, so that means this other negative has to apply to the actual coordinate value. And our radius is going to be the value that's squared. So our center is going to be 7, -2, and our radius will be 8. Another way to think about these problems is that if you look at the formula, your center will always be the opposite of what it looks like. So it looks like a -7 and a +2, but the center actually turns out to be +7 and -2. And the radius is always the square root of whatever our final value on the end is. So the square root of 64 is 8. And that's just another way to think about those particular types of problems.